What's up, guys? I'm here in another video, and today we're going to go through a particular topic in inorganic chemistry, which is called denticity. So let us begin with what denticity is. Denticity basically refers to the number of times a ligand can bind to the metal center. So denticity specifically, in other words, it refers to like the number of attachment points or the number of sites where the ligand directly attaches to the metal center. And so in this video, we go through a few examples of what different denticities could refer to. And so I would like to start from the lowest denticity to the highest denticity. So we can take a look at an example of this compounded right in the middle of the three, where we see 4 ligands attached to the metal center. And so because you see that this ligand is attached once through a single bond, this would be considered as a monodentate ligand. So, and this would also be considered as a monodentate ligand. So, monodentate that means it bites, in quotes, it bites the metal once, right? Which means it has one point of attachment. So that's basically what monodenticity refers to, a denticity of 1. And denticity kind of sounds like, dentist. So that's where you can get the idea of biting, because it's like we use our teeth to bite. And so in this case, hypothetically speaking, the ligand is acting as a teeth, which is biting on the metal through this bond. So it's directly attached to this metal. That's a monodentate, and this is a monodentate. So these ones can also be considered as monodentate theoretically because they're bonded through one bond. But the thing is, like, there's a whole lot going on with this structure, because this structure has a hapticity. Hapticity basically refers to the number of carbon atoms associated with the ligand bound to the metal center, but I'll get to that in another video. We can look at the example of this. So in this, there are 2 types of denticity. There's the monodentate and there's the bidentate. Monodentate is 1, bidentate is 2. So because this binds to the metal once, it's 1 monodentate. Because this chlorine also binds to the metal, you would think that it's bidentate, but it's still monodentate because it attaches to the metal once. This chlorine atom attaches to the metal once, just like this one. But when you take a look at the nitrogens here, these are bidentate because they attach twice. You have a point of attachment here, which is directly attacking the metal. At the same time, you have a point of attachment here, which is attacking the metal. So this is twice. Like it's like some sort of claw, it's like some sort of claw that directly interacts with the metal. And so this kind of denticity is bidentate. Why? Because this ligand is fashioned, it's arranged in a ring fashion, in a ring structure like fashion. And so this would be considered as a bidentate as opposed to these 2 chlorines, which are actually monodentate. And so allow me to circle the nitrogens. Nitrogen circled, and they are bidentate. This one too as well is bidentate, okay? So now we move on to our last structure for today. So you see two methyl groups and a whole ligand, you know, a whole ligand coordinated to the metal center, this metal center. So what would you think this is? Well, there's one point of attachment here from the oxygen to the metal center. There's another point of attachment from the oxygen to the metal center. And there's also another point of attachment from the nitrogen to the metal center. And they are all arranged in this some sort of ring structure-like fashion. And you might even consider this as a pincer fashion. But we'll get to that in another video. That's quite different. So what would this be? This would basically be tridentate. A denticity of 3 is tridentate. So this atom, and this atom, these are all tridentate ligands because they have 3 points of attachment to the metal directly. This would just be monodentate. Again, I'm just going to shade it out so that you don't get confused that those are not tridentates, those are monodentate, and this also is a monodentate. If it were arranged in some sort of ring structure like fashion, we can consider that to be a bidentate, but they are directly attached through a single bond with nothing else in their structure. So we can consider those as monodentate ligands. Monodentate ligands and a whole tridentate ligand sitting on top of the metal center. I hope this was helpful in you understanding what denticity is, and I'll see you in another video. Bye. Please like and subscribe, and I'll see you.